Hello, I'm Kaylee Hutchins, editor for Data Center Review, and today I'm sitting down for a chat with Dave Wolfenden, founder at Heatload. Welcome, Dave, and thanks for joining us. Let's jump right into it. Can you give us an introduction to Heatload and the services it provides?
Sure. Heatload's been going since about 2002, and it comes out of my background as an IT program director for building data centers. And at the time, I wasn't that impressed with the way data centers were being tested that I was taking over on behalf of customers. So at the time, we thought there must be a better way of doing this. Instead of going to Argos and buying thousands of heaters, and some of them caught fire, some of them had thermostats removed, they weren't very reliable, they were cutting in and out. So we just thought this is not a good way of doing a data center test. So basically, we came up with some products that we designed with a couple of the big consultancy companies that had a better delta T. So the airflow and the temperature rise matches that of servers. And we've been going, 21 years now. And we test about 200 to 300 data halls a year. So yeah, incredibly busy. We've got nearly 100 megawatts of load. We just ordered a load of new equipment, a new product which we've designed, which by Christmas will be over the 100 megawatt amount.
Wow. So just briefly, for a bit of background, what is immersion cooling and how does it work?
Okay. I guess the simplest way of putting it is that a liquid is much more efficient at taking away heat. So if you were to go and stand on the beach and it was 10 degrees, you would get hypothermia at some point. However, if you went into the sea and the water was 10 degrees, it would transmit the heat away from your body much quicker, much more efficiently. And that's the same with servers. So it's a much more efficient way of taking the heat away from the processor chips, the memory chips, etc. And as we're seeing that the actual capacity of each server in terms of kilowatts is just going through the roof. I read an article recently where they're talking about much higher densities than we're even seeing today. They're talking about 300 kilowatts in a rack potentially. And the only way of really doing that, air just can't do it. So it's got to have to be a liquid. The liquids they use are inert liquids, so that they don't conduct electricity. You can drop your phone. I've seen the exhibitions where you just drop your phone in a tank and it carries on working. So that's the sort of technology they're using.
Thanks so much. So what's the advantage data centers of using immersion cooling as opposed to traditional air cooling systems?
Really, the density of how much equipment they can get into the same space.
Yep.
It's not all about the size of the facility. A lot of systems that I worked on when I was doing IT migrations work better with the chips much closer together on the board. So the densities are increasing because obviously the amount of time it takes for a signal to pass around a printed circuit board is far greater if the board is huge, whereas if it's all crammed into the smallest space possible, it's going to get hotter, quicker, and much more denser. So the immersion cooling will take away that heat much better than air cooling.
So how does commissioning immersion cooled units differ to traditional cooling units such as air, for example?
Yeah, sure. I mean, air, as you say, is traditional. It's fairly simple in that effectively you're using an electric fan heater to create electrical load and you're using a fan to move the air. So you simulate that if a server's got lots of fans in it and it consumes electricity, so it produces heat, that's what a traditional air cool system does. Mm-hmm. Immersion, when you're preparing a server to go into an immersion tank, you take away all the moving parts, including the fans, because that will play havoc with the flow of liquid within the unit. So really, our units are immersion units, in very simplistic terms, a bit like your immersion tank in your loft. It's a sealed unit with grills at the bottom to allow the cold oil into the bottom of the unit, full of elements. And then the elements heat the liquid up, and then through natural convection, the heat rises through the unit, and then out the top through more grills, and then over a weir into a cooling circuit, and then back round again. So our systems are literally a cage with some fairly specific, special elements in them.
Yeah.
Because one of the conditions you have to be very careful of is surface temperature. It's not as simple as putting in an element and hoping for the best. You've got to look at the surface temperature of the elements that you don't end up scorching the liquid.
Yeah. Okay. So thinking back after the last couple of busy years, why did Heatload originally move into the immersion market?
It's a market that we see evolving quite rapidly now. When you see some of the articles on some of the social media platforms about who's doing what with new servers and new data centers. And of course, we receive probably 100 to 200 design documents a year from big hyperscale data centers that we're currently testing. We're currently testing 6 hyperscales. We're quite a small company. So we see these documents, and what we started to see in the last 18 months or so is on the design documents, it starts talking about having cooling circuits to allow for cooling baths. Whereas traditionally we'd see a cooling circuit with room air conditioning units on. Now we're seeing tap-offs, etc., to allow the connection of direct cooled or immersion tanks within the data halls. And these are starting to see quite large-scale ones in that we saw one recently which nearly a quarter of the building would be immersion-cooled tanks.
Wow. That's significant.
Absolutely. And we took a business decision that if you don't evolve as a company, you die.
Yeah.
So we, middle of last year, started to look at designs and thinking about how best to come up with a product. We developed a product which we then took to the States and had it tested at one of the largest immersion tank manufacturers and developers. And subsequently, it's now been design's been changed and developed to meet their requirements, and has now been tested by several other providers. And now it's actually gone into production in terms of we now own nearly 600 kilowatts of immersion units. And we've done 3 or 4 small implementations for testing and commissioning. And we just started another one this week, and we've got 2 more next week. So it's starting to snowball. So we see it as a growing market. We see it as the future. Whether or not it's the only solution that'll be out there, we're not planning on getting rid of any of our equipment for testing air-cooled data centers. In fact, we're actually developing new products for that market because we see that market going forward, because we see that different IT applications have different requirements for servers. So one solution does not fit all. So, we want to be part of the action in that we want to have solutions for all of the market.
Yeah, it's about adapting and thriving to the changing market.
Absolutely.
And why would a customer choose to rent emulators as opposed to actually purchasing them?
They are fairly expensive to purchase. You can imagine in the old days when people went to Argos to go and buy heaters for testing data centers, they go and buy 2,000 or 3,000 of these mass-produced heaters, which you can buy for like 20, 25 quid. Our manufacturing costs are 7 to 10 times that, because they're very specific about, especially with the emulators, they've got special fins in them to dissipate the heat, etc. Now, that means that they're made in small production runs. Anything that's made in small production runs costs more. So what we would say is that first instance is, yes, it's a lot of money. The second instance is that it's not environmentally friendly, in that if you build a data center and then you buy a bunch of either immersion units or air-cooled units, whatever you're looking at, and then you put them in the skip afterwards, that's really not good for the environment. Everything we do is reused, down from our packaging, for our equipment, all the cables. And the third thing is that every installation is different. Some customers build data centers speculatively, so they need us to provide temporary power connections. Others provide a power connection, but it's different to the room next door. And
Yeah.
it might be 3-phase, it might be single phase, it might be 32 amps, or it might be 63 amps. So we provide all of the connectors in our warehouse, and then we test it all, send it out, do the job, take it away, refurbish the equipment, clean it, and then prepare it for the next job.
Yeah.
So for us, it's about the reuse of the equipment.
And that is a big topic within the industry and the world at large at the moment: sustainability, circular economy. So, and sort of leading in, off from that, looking ahead as everyone gets this question, what does Heatload sort of see as the forecast for the immersion market over the next sort of 5 to 10 years?
That's quite a question to ask.
Yes.
You'd have to ask the immersion cooling companies the real answer, but we see it snowballing. We do see. There are some other types of cooling that will probably come along, which are things like the direct cooling to the chip, which we will be looking at products how to do that. Because one of the advantages of using our products is that if something goes horribly wrong in perhaps the upstream cooling fails, okay, if you damage one of our emulators, it's a small amount of cash. Whereas if you take out a £250,000 network switch because your cooling failed during testing and you testing using live equipment, it'd be colossally expensive.
Yeah.
So the future, I think it's going to be a hybrid solution, and the data centers will be a mixture of air-cooled, immersion, and direct chip cooling.
Which is very much what you said, wasn't it? Not one size fits all, which is, we hate that phrase, but it is true.
Absolutely true.
Well, thanks so much for your insight today, Dave. We really appreciate it. And thanks again for joining us at DCR.
Thank you.